testing the difference between the means. The large independent what? Sample. Don't forget this is 2 means. Alright. Okay, so what do we need here? Yeah, it's still the same idea, okay? The null hypothesis will come in, the alternative hypothesis will also come in. And you know that the null hypothesis is for it deals with what? Less than or equal to, greater than or equal to, and what? Equal to. And the alternate hypothesis also is about what? The less than, the greater than, and what? Not what? Equal to. It's the same thing here. Alright. What you also have to know is that here, to write the null and the alternate hypothesis for a 2-sample hypothesis, test with an independent sample, we translate the claim made about the population what parameters from a verbal statement to what? A mathematical what? Statement. It's the same as what we're doing there. Alright. Then, write 8 complementary statements. For instance, if a claim is about 2 population parameters, let's say P1. Now here, since here we are dealing with 2 means, it's not 1 mean. 1 mean is about 1 what? Parameter. So that's why we are getting something like mu less than 0.5 and all that, right? Good. Here it's more like that. Here we are saying that you are going to write the complementary what? Statement. For instance, if the claim is about 2 population parameters, that means that here the claim is going to be between 2 what? Parameters. Let's say mu1 and mu1 2. So it's going to be we are going to consider 2 what? Parameters here. That is mu1 and what? mu2. Alright. Good. So this is how our claims are going to be. Let's say we have the null hypothesis and the alternate hypothesis. Alright. So if in the statement it's talking about equality or something which is certain, alright, so that means that our null hypothesis can be in the form this is equal to that. I'm just giving you the form of how we are going to write our what? Our hypothesis. And when we get to the question, you know what it means. So here, your number will come here. It is between 2 what? Parameters. Okay, so the alternate will be not equal to that. Alright. Another one is that we can get a null hypothesis and the statement is between less than or equal to u2. Then the alternate will be greater than u2, right? And we know that with this one, it's still the same as we writing it for equal to. Right. We can also get this. The alternate will be. So this one, the statement is just going to be between what? 2 parameters. Alright. And you know that this one is what? Equal. Will be equal. Alright. So that's how it's going to be. Regardless of which hypothesis you use, you always assume there is no difference between the population what? Means. You always assume there is no difference between the population means. So always this side is what? Equal. Alright. Good. So now let's see the requirement. Alright, so the requirement is very necessary, as you know already. Alright, so the random sample, this guy always. So the sample must be independent. Yes, it must be independent. And now you know how to identify whether a sample or 2 samples is dependent or what? Independent. Alright, so 3. the sample should be greater than or what? Equal to what? 30 or normally what? Distributed with a known standard what? Deviation. With a known standard what? Deviation. Don't forget that. Alright. And that known standard deviation we are talking of is the population standard what? Deviation. Alright. There is something that we have to define here before we move on. This is the mean of the difference of the sample. The mean of the difference of the sample, that's how it's going to be. So you see where the point estimate is. So now we are dealing with two things here. We are dealing with B1, B2. So we are going to get 2-point estimate. Okay, S bar 1 and S bar 2. So that is that. The standard deviation 2 is going to give it to you in this way. So we are going to use the already formula, but we have to fill this one, these things what in. Alright. So that's what we are going to have for that. Good. So now let's move on. Alright, so let's move on. The standardized test statistics. So you see, when we're dealing with one sample, we have the test statistics for the large one sample. That is when n is greater than 1, or for the z-test one. Hope you remember that formula. Where we are having the S bar minus the mean over the standard deviation, that is the standard deviation of the population, over the square root of n, right? Good. But here, that one here is now transformed to this. So everything in the denominator here is going to be this. And here we will not also maintain S bar, but going to be S bar 1 minus S bar 2, since we are dealing with what? 2 sample. Same thing here. And if the, okay, so here is not test statistics, it's standardized test statistics. If the null hypothesis, this, that, or that, then U1 is equal to what? U2 is the assume. This one I have told you already. Because whether not equal to that, not equal to that, we assume all to be. We assume and the expression of what? U1 minus what? U2 is equal to what? 0 is the preceding what? Test. All that is saying is simple. You see, if you have U1 is equal to U2, it's the same as U1 minus what? U2 is equal to what? 0. So in the claim, you can write it this way or that way. They are all correct. In fact, in some books, they make it U1 minus U2 equal to 0. So let's see the steps that we are going to go by. The steps. It's already what you know already, okay? It's something that, so you state H0 and what? H1. Yes, but here it's going to be within 2 parameters. 2. Identify your alpha. 3. Determine the critical value. So you determine your critical value here. And 4. Determine the rejection rate. So in this session, we are going to base on the traditional method and go our way. 5. Find the Z, which is the standardized test statistics. 6. You make a decision. Then lastly, you interpret your results. That's all that we are going to do. But when the question is there, for you to identify that it is large sample, and the most important is that, is it independent? That is the most important thing. I'll be back. Well, in the world is even me. Yeah, that's it. So that's our first question, and I'm testing for difference between beans. That is the large word sample. Please forget that the topic is independent. So definitely this question is going to be independent. Yes, it's going to be. But let's see how we are going to come out with it so that you understand it well. Okay. All right. A credit card watchdog group. So there's a credit card watchdog group. Claims that there is a difference. Claim that this statement is very, very, very necessary. claim that there is a difference in the mean credit card debt of household in Accra and Kumasi. In Accra and what? Kumasi. Alright. The result of a random survey of 250 households from each state are shown at the left. Do the results support the group's claim? First of all, you need to identify whether this question is independent or what? Dependent. So simply you can see that it is independent. How can you see that? The question is talking of a group, and inside the group, he is considering the households in what? Accra and what? Kumasi. So this is straight away, is independent. Alright, good. Now, something we are not giving in the question, let me define it here. So let's see the sample statistics for the credit card debt. So we have the one in Accra. Let me give to you in table form and Kumasi. Right. We have the X bar 1 to be 4,446.25. And we have the S, that is sample standard deviation. All these will be given to you in the question, okay? Don't worry. 104570. And then this one will be 20. Alright. And here the X bar 2 is going to be 4,567.24. Then the second one 136.1.95, and N2 is going to be 250. Alright, so yeah, the sample size are the same, no problem. Alright, so let's see. So all these are going to be given to you in the question, right? Okay. These are point estimates for the what? For the mean. So let's say if this one was filled in the question, you see that the sample standard deviation. Remember here, we are not giving the population standard deviation. If the population standard deviation, that would be this. But this is the what? The sample standard deviation. So in the question, you will hear something like the sample standard deviation are this and this. That means that the first one will be your S1 and the second one will be your S2. And this one too will be the mean. The question will tell you the means are this and that. That one too should tell you that it is talking of what? This. Alright. And the number of samples is that. Okay. So let's see what we have to find. So first of all, before we do the results support the group's claim. First of all, we have to go through the steps, the 7 steps that we have. The first one is to do what? Is to state the what? The H what? Not. And then H1. That is the alternate and the what? Oh, I'm cleaning it. Don't worry. You have it, so first of all, how will you state 1? How will you state your H0 and your H1? So when you check the question where I underline it, it says that there is a difference in the mean. There is a difference in the mean. So if it's different, you have to know that the claim says that there is a difference, right? So you know that it's going to be what? Not what? Equal to. So that means that the H naught of this, but this one will be mu1, will be equal to the mu2. In fact, this one will always be equal to the mu2. Then the H naught, the alternate hypothesis, that the H1 is going to the mu1 not equal to the what? The mu2. Yeah, you are not going to equate it to any number. No, you are not going to equate it to any number. So you can see that this is the claim. You can see that this is the claim. Okay? Alright. So second step. The second step says that we have to identify our alpha. And the alpha was given to us in the question to be 0.05. It's very important to identify your alpha. Alright. The third one, to determine the critical value. So we have to determine the critical value, no problem. So you know that it's going to be two-tailed test, right? You know these types already. So this is going to be alpha over 2, alpha over 2. So divide this by 2. And when you divide this by 2, what will you get? That is 0.025. 0.025. Beautiful. So you determine your critical value here. That one here. And you know that this is going to be negative 1.96. 1.96. Alright, so that is going to be that. So after identifying your critical value, then please, not all the questions that these things will be given to you in a table form. Sometimes you identify it from the question, and I'll give you such example. Alright, so the fourth stage, all these are something that you know already. The fourth stage is to determine the rejection region. And how do we determine the rejection region? This is a traditional method. And to determine the rejection region, you need the standardized test statistics. So Z is equal to, you write your formula there. Alright. Let me see if I can code open. Because I know it's linking to the other one. And that one is S bar minus 1, the B. But here in dealing with two means, that's why we're having the 1 and the 2. All this over. I know that that one, if it's dealing with population standard deviation, it's going to be something like this going from N. Right? Good. But this, from this question, what we were giving is the sample standard deviation. Don't forget. So it's not going to be this. Since it's 2 mean, it's going to be S1 plus of what? Sorry. S1 squared plus S2 squared N1 N2. Alright. Do you know that this is the same as watch? I'm going to square this. I'm introducing a root here. So I'm squaring this to undo it. So that this one will come here. Right? And when this one comes here, it's the same as this. X squared over what? N. You know the same thing. So it's the same idea. Okay? So that you can know, you don't need to chew all these boy stuff. Alright? Know how to make it. So it's the same thing. That's why we bring the square there. Now, but our N1 and N2 from the question is the same thing, right? So we can make it all over N. Since from that is the same thing. But you know what? I don't want to worry you. Let me leave it like this. Because not all the same is the same. Not all the question is the same. So your standardized test statistics is going to be. Alright, so let's go. We are going to have it this way. Oh, what is this? First of all, let's go. We know N1 is what? 2 250, right? N2 is what? 250. Good. Now let's move on. That means that from the question we know x bar 1 to be, that's the point estimate, to be 446.25. And we know x bar 2. All this is the mean. The mean, that is 4, 5, 6, 7.24. Good. We also know our sample standard deviation to be 104.5.70. Alright. And the second one to be 1361.95. Alright. But there is something here that we don't know. We know this N1, N2 is here, this one is here, but we don't know this. The mu 1 and the what? The mu 2. And it was not given in the question 2. In the question, all that we know from there is what we have here. It was not given in the question. Please, let me advise you. With this, don't think of it. It's 0. It's 0. Okay? So, this mu 1, this mu 1 is 0, the mu 2 is 0. So all of that is what? 0. Do you know why? Do you know why? Should I tell you? Should I tell you? Let me tell you, okay, so that you understand it more. I love you. I don't want you to be misunderstood. We are saying that mu 1 is equal to what? Mu 2. Is that also from the hypothesis? That means that, are you watching? If mu 1 is the same as mu 2, and you are saying that mu 1 is equal to mu 2, can be written as mu 1 minus the mu 2 is equal to 0. Right? And this is the same thing. That means that it will be 0. So everything will be 0 is equal to 0. That is why that thing there will go 0. So all this. Or you can also say that we are saying mu 1 minus mu 2 is equal to 0. Simple. We are saying this is the same as you writing it as this. That is simple. All this is 0. Yes, always use the traditional method here. So substitution, man is tired. Let's continue. Substitution. So we are going to get 46.25 minus 45.67.24 minus 0, because all that thing is what? 0. All this over 1, 0. That is the first standard deviation, the sample standard deviation. Okay, and the whole of this is going to be equal to negative 1.11. Please take your calculator and test it. Always don't trust my final one. Alright, so that is what we are going to get for that. So now, traditional method is not what we are using. So we use a z-test to check where it's going to fall within. So if it falls within the rejection region, then we know what to do. So this one is the rejection region, and this one is the fail to what? Reject. Simple. Let's move on. Alright. So clearly, we can see that. So the graph at the left shows the location of the regions of the rejection region that you know already, and the standardized test statistics Z. Because Z is not in the rejection region, you should fail to reject the null hypothesis. Let's see. Negative 1.11, where will it be? You see, negative 1.11 will not be here, and 1.112 will not be here. So, because here is 0. You see that here is 0. So that negative 1.1 will fall within here. So it will still be in the fail to reject what? Region. So that is that. Let's see how we are going to conclude. So now our decision is that because Z is not in the rejection region, are you writing? Because Z is not in the rejection region, we will fail to reject what? The null hypothesis. And conclude that. So now this is going to be our interpretation. This is going to be our interpretation. Are you ready? Now you are failed to reject. So what are you to me? There is not, or there is no enough evidence. There is no enough evidence at the alpha level of 5%. Sorry, 95%. 95% level of significance to support the group claim that there is a difference in the mean credit card depth of household in Accra and what? Kumasi. So yes, simple. Yes, simple. Alright, so you failed to reject, so no evidence, that's all, you go your way. Thank you. I'll be back with a question for you to try it on your own. Alright, good. Alright, so this is your trial question. Let me help you some more. A survey indicates that the mean annual wages of forensic science technicians. So we are talking about a forensic science work technicians working for a local, working for what? A local and what? State government. State what? Government. Don't forget. So here it deals with two samples, right? So you can see that we have those working for the local government, and we have the ones working for what? The state what? Government. It's independent. That's how we indicate the independent. So this person is independent. This and that, respectively. The survey includes a randomly selected sample of size 100 from each government branch. That means that our N1 is 100, our N2 is 100. The sample standard deviation. No, the first question was sample, so let me change this. The population. The population standard deviation are this and that. So this is for the local and this is for the what? The state. Then you have the upper level. Is there enough evidence to conclude that there is a difference in the mean annual wages? That's what we are going to do. You are going to do. So I'm going to help you to identify some things. Alright. So let me help you to identify the X bar. That is the mu1. and then mu2. But that is just simple. That is what is here. Even though we didn't hear any mean there, but you see it's here. And so we indicate that the mean annual wages of forensic science technicians for working for local and state. Local and what? State. So the local will stand for 1. The state will stand for 2. So like N1, N2. The N1 is for the state and this is for the local. The local is the 1 and this is the 2. Alright. So there is no full stop there. And state, government are respectively. So that is the mean. And as I told you, it's not this mean I'm talking of, but rather the point estimate. So we have 3,300 here. Then 5,110. That is for that. Alright. What is left again? Then we go for the population standard deviation are, you know that population standard deviation is this. So the first one is for the local. Then the second one, 5,575. Alright, so that's going to be that. At alpha is equal to 0.10. So that's your alpha. Use it to go by 8. Alright, so see you in the next video. That is when we are going to work where we are having a small independent sample. Alright.